start, we've seen the layers of rock. How do you take those layers of rock and bend them like that?
Force.
I'll show you something. These layers, they're bent, but they're not shattered. There's some breaks in them as they're eroded. But if the rock was hard and you bent them, what would happen? You just have a pile of gravel. So what that means is that these layers had to be bent while they were still
Soft.
We call it plastic.
Yeah.
Okay? Plastic is a scientific term. It means you can bend it and it won't readily break.
Okay, where is that?
I don't know the answer to that question. I hate to admit that, but it's just the way it is. It's all over the place. There are some rock formations in Grand Manan just like this.
Did you take
But I
that
don't
one?
know.
Did you take that?
Not that one, no. No. So, many strata appear to be laid down in rapid succession and remain temporarily pliable, enable them to be bent and folded without fracture. Okay? Diagenesis. It's removal of water. So, diagenesis is when a rock layer is there, as the water is pulled out of it, it cures, just like cement. Okay? If you've ever worked with cement, you know you pour it, and then all of a sudden all this water starts appearing on the top. And as the water comes up, the cement gets hard. Okay? Now, cement will even cure underwater, you know. I mean, you can pour cement underwater, and it will extrude the water out of it and harden. So this happens, this hardening of the rock. So what happened here is that it got bent before it was fully cured or fully dry. Okay? There's very limited fracturing there, and that's just one of many pictures I have. Look at the size of this. Okay, so you've got these layers that go literally for miles. How do you bend those rock layers without them just shattering? Have to be bent when they're wet. How do you bend that amount of mass of wet rocks? We were just talking about some of the other things that happened to the flood. It's not just about water. Water coming up, water coming down. That would have broken up the tectonic plates. That would have allowed volcanoes to surge to the surface. That would have caused earthquakes. That would have caused many of the natural disasters we're used to seeing. There would have been tornadoes spawned because the water would have been superheated by the volcanoes. And so you've got a very hot ocean. Now, as the volcanoes are spewing out their heat and volcanic materials, what are they doing to the sun? Blocking out the sun. So you're going to have a really interesting world picture. Hot oceans, cold atmosphere. Where's it going to be the coldest? At the poles. It's where the ice age comes. It's just merely the poles growing down over the continents. That's what the ice age is. So you've got evaporation of the oceans into the atmosphere, and then it comes down on the poles, and you grow these huge ice blocks up there. Okay? So here's something interesting. And we just talked about Mount St. Helens. We're going to talk about Mount St. Helens a bunch, because Mount St. Helens is a fantastic test case that helps us to see where multi-layers can come from, and how they can bend, and how long it takes. Now, if we're already talking about this, who knows, when did Mount St. Helens blow?
May 18th,
1980. 1982, something else happened. And that
Another
was where Spirit Lake broke open, right? And this huge amount of water just... We're going to come back to that. I'm glad you know about that. Okay, you were there?
I lived in Washington.
On the mountain?
No. I'm good, but not that.
Yeah, so you were there. Anybody else in Washington? Yeah? So you all got to experience the lovely ash
Oh, yeah.
dump. Yeah.
Felt like hot rain when it landed.
Oh, you were... Nah. That's scary. Yeah.
It was amazing. I mean, it looked like a big storm kind of blowing over, but the clouds kept getting closer and billowing.
felt the
fine,
ash
hot
coming
stuff.
down on it.
Wow, that's scary.
But
So,
it's right.
so now you can imagine what would have happened if literally thousands of volcanoes are going on all at the same time.
It ruined the fruit crops for 2 years.
Yeah? Oh, those lovely peaches and yakima.
Apples,
Oh, that's too
Cherries.
bad.
cherries.
Yeah.
Yeah.
Look at this. The bending of the rocks, I mean, it's quite a bend, and what you see when you look with a microscope is you don't see crystals breaking, you just see that pattern. Look at this one up here, how small and thin, and yet how precise it is. You see, they were plastic, meaning that they didn't just flow into each other. They stayed in their own lane, but bent and contorted. Doesn't matter who you talk to, they will agree the only way that could happen is if it was plastic rock or pliable rock. Look at this one. Isn't that interesting? That's rock. Every one of those is a layer that was laid down, and then something buckled it, pushed it from the side.
So there could be lava rock, right?
Oh, why not?
I mean, lava means that they were liquid before, and just,
So you're exactly right. Where we were this summer, there's a big cliff system. It's called 7 Days Work. And along 7 Days Work, you will find layering and bending. But here's what it had to be. It had to be a layer that went out and went down and around, cooled. Then the next layer was deposited, cooled. So all the layers couldn't be together and then bent, because once lava cools, it's hard. I mean, that's this stuff. You can't bend this stuff. It's solid. So it can look like it's bedrock, but it's really not bedrock. It's just poured in a bent fashion. However, with these guys, they could show that all those layers were deposited in a short period of time all at the same time, and then bent, which is really different. So, I have that picture up there, but let me get you the explanation for it. These are things that have been fossilized, okay? Found in the fossil record. So this is a miner's cap over here. It's as hard as rock. It is rock. The rock, just like a lot of fossils are rock. And these teddy bears here, they're also hard as rock, calcium.
Dripping down on them.
Yeah. So the question is, how long does it take to fossilize something? And the wonderful answer is, well, it depends. What does it depend on? Well, it depends on what minerals are around. This is a stream that is really full of, what's that stuff that gets crusty around your sink? Yeah, lime. So these guys absolutely turn into lime fossils very rapidly, like months, couple months, and those are all, they're literally taken and sold at a tourist trap as fossilized teddy bears.
Oh, geez.
Okay? It can happen quickly if the right materials are present. Fossilization does not require a huge amount of time. Okay? So you have the miner's hat there, and so you have the ability, if you have calcium carbonate around, it will go into the material and mineralize it. Fence posts, put them in the right place, from the ground down, they'll literally turn into a fossil. So you have a fence post that the top is wood, and the bottom is a fossil. Because what the fence post, the wood, it functions as a pattern. Just like the teddy bears, that's just the pattern. And the minerals flow into the pattern and form into rock. Okay? That's the way a lot of fossils are formed. So it doesn't require a long time, it requires the right conditions. What's this third one over here?
tree.
That's a tree.
Is that petrified forest?
That's at the petrified forest. A tree, and you can see growth rings. You can literally tell how old that tree is. We have some petrified wood up here that's just very interesting. What's happened with the tree? It just was a mold for the minerals to flow into and turn into rock. So, number 8. I love this one. I love this one. In fact, I have a whole handful of these guys up here. These are clams. clam fossils. So I was at a rock quarry. Rock quarries are great places to go and look for fossils. And I was just walking along and I just picked these up one after another. And it's like, those are clams. Well, around the world, when you find clam fossils, they look like this. What do you notice about each clam?
Closed.
They're all closed. They're all closed. What do you know about going to the beach? When you go to the beach and you find a dead clam, is it closed or open?
Oh, usually open.
It's wide open. It's open because the muscle that holds it together, as soon as the clam dies, that muscle relaxes, the shell opens. So what do you know about these fossils?
Got buried quick.
They were alive when they got buried,
Right.
so they're buried alive. Does that fit the evolutionary mindset? Okay? If it's evolutionary, we should see all kinds of different shaped clams, and they should be allowed to die. But the fact that across the world you find these mollusks tightly shut, they must have been buried alive, and that gives evidence that the flood was rapid and wide scale. This is the type of thing you find in the top of Mount Everest. I would think that if you carried a clam all the way up to the top of Mount Everest, it would have an open shell by the time it got there. There's the beach. That's what it should look like. It'll still fossilize, but it'll be a very different fossil.
It will warm up just a little bit.
Hmm?
It doesn't take much for them to warm up.
Yeah. Okay, there are some things that creationists struggle to explain with the fossil record. And this is maybe one of the most important points we can keep in mind, is that nobody has it all figured out. So let's not us be arrogant, and let's not them be arrogant. Let's have a conversation. We have a lot to learn from each other. Some of the worst things that happened in science when people didn't talk to each other, whereas if they just shared the information and the things they had learned, we could have been far ahead of where we are now. So here's one. There's a substantial challenge to the flood scenario is that various dating techniques consistently show the lower layers of the geologic column to be older than the upper layers. We would expect the bottom layers to be laid down before the upper layers. That's like a no-brainer. But when we test it with potassium argon or with some of the uranium dating methods, it's significantly older. So that makes it look like those bottom layers with just the single-celled organisms are ancient. What do we do with that as creationists? We say that the flood happened in 1 year. Same year. That all the layers should be the same year old. It's a hard one. It's not that creationists don't have ideas. One of the ideas that as creationists we say, well, the upper layers, just the way the dating methods work, the upper layers would have more opportunity for daughter products to be washed away and parent products to be added. In other words, it's not a closed system the further up you go. The deeper layers are going to be a closed system. Top layers, stuff could be added or removed. I'm not sure it explains a whole lot, but it's an idea. It's a thought. Okay? Another option is that carbon-14 levels were less back in time. Okay, so how do we think this through? What makes carbon-14? Remember we talked about it. Radiation. Radiation creates carbon-14. It knocks neutrons around and creates carbon-14. So if you've got heavy solar radiation, you're going to have higher levels of carbon-14. So, as time's gone on and the ozone layer has been depleted, today we have higher levels of carbon-14 than they did in the past. If we take those ratios and apply it to something that was grown, a plant that was grown, in a time when carbon-14 levels were low, there would be less daughter products in that one. So that will look older than it really is. Don't worry, just understand the fact that with changes in things like the amount of carbon-14, it messes with the science of radioactive dating. Okay? Here's another issue. There are no mammal fossils associated in any way with dinosaur fossils. When you get to the layer that has the dinosaurs, all you have are dinosaurs. No mammals. Not just no humans, but no mammals. How do you explain that? Well, maybe the dinosaurs ate all the people. I don't know. There's just some things in the geologic column that leave creationists scratching their heads.
Yeah, because there were horses and all, there were
Well, there's
several
lots
other
of fossil
mammals.
horses. There's lots of fossil mammals.
No,
They're
but I
just-
mean from that period of time.
There would have had to be.
Yeah.
Remember, one of the way we can explain this is with biome succession. Who's going to be buried first? Dinosaurs, that with everything we know are cold-blooded, or mammals?
Dinosaur.
You see, snakes seize up. If they're cold, their muscles don't work. So maybe that's why at that point in time, with cold rain coming down, we don't have it all figured out. Is that news to anybody? I mean, there's so much that we have no clue about. All we can say is that so much evidence points to a flood, there's an explanation here somewhere. Give us some time.
Can I ask you?
Yeah.
You made a comment to, you think the flood lasted 1 year. Is that 1 year of our time or 1 year of Bible times? Which would think probably been longer than our 1 year.
Okay, she has a very good question. So in the Bible it says that for 40 days and 40 nights the rains fell, and then for an additional 150 days they were in the ark, and then God said, okay, open the door, let's go out. So give or take less than a year. In the Bible, when it talks about 150 days, the word day will be yom. That's the Hebrew word. Anytime yom is used with a number, it always refers to a 24-hour day. So a day is 1,000 years, not here. So if we read it and take the simplest explanation, it was literally less than a year between the beginning of the flood and the flood.
I was thinking, really longer than a year.
Uh-huh.
Count for the difference.
Uh-huh. Nice thought. I love that thought. But it doesn't seem to fit the Bible.
So you're saying
Yeah.
that it took the waters at least a year to recede?
Yeah, I have to get my Bible out and look at the numbers, but it's less than a year start to finish. Yeah. Which is incredible that all that water could go somewhere that fast. Yeah, great question. Yeah.
Does the sun give off microwaves?
It gives, yeah, there are some microwaves that come from outer space. Sure.
So could a microwave be more affecting the upper crust more than the lower crust and keeping them like younger, whereas these lower ones aren't getting any radiation at all from solar and they're staying.
See, that's a whole great thing to think about. Is there some kind of radiation that would affect the
Microwaves.
action of the,
Top levels of soil.
yeah,
You know? And the deeper you get, the less penetration of that microwave from the sun.
it's worth investigating. See, that's why we don't know it all, is because we haven't, that there's so much to learn. Absolutely. Okay, everybody gets that? All right, let's jump over here. Things that evolutionists struggle to explain, and I love the fact that this list is much longer. Okay? Number one, the sudden appearance of life. All of a sudden, there's life. There's no precursors to it. All of a sudden, there's living organisms. They can't explain that. They say things like, well, maybe there were other pre-life organisms, but they didn't fossilize. Well, you can't say that, because if jellyfish can fossilize, those creatures should have fossilized as well. Maybe it was destroyed by metamorphism. No, because the layers are there, they're just totally empty. Okay? Early form, so, second one. Number two, the sudden diversification of life in the Cambrian explosion. Cambrian explosion, you go from these tiny, eensy-weensy, simple creatures, and then all of a sudden you've got cats and rats and elephants and all these other things. Just boom, just all of a sudden, boom. Cambrian explosion. How do you go, okay, if it's like evolution is saying, it's this tree, that tree, you should see the roots, the trunk, a few branches, more branches, some foliage. You should see this growing, but it's not like that. It's like, boom, it's a bush out of nowhere. Okay? The lowest fossil containing rocks begin suddenly with a wide variety of animals, no gradual development and diversification in the rock forms. Just boom, we have all the variety in all its grandeur all at once. Okay? There's no explanation had that evolutionists can come up with. Let's go to over here. And I talked about these a little bit before. They're called polystrate fossils. Poly means many. Strata is layers. Fossils that extend through many layers. So here's an example of one. Check out this. Not only do we have the tree, we have the roots. So the roots are living, growing in a layer that is several million years older than the trunk. And logically thinking, before it broke off, there probably was the rest of the tree going up there. Polystrate fossil. How do you explain that? How do you explain that a tree grew through millions of years? Because it doesn't have enough rings. Just in case you thought about that, you can count the rings, and there's not enough rings for a million years worth of time to go by. Polystrate fossils are not rare. There's lots of them. So don't just tell me, well, that's a special case. No, these are not rare. Okay, so you have, this is in Kentucky, in a coal bed. Look at this guy. That is, have you ever heard of horsetails? You know, you can pull them apart and put them back together again. That's horsetail, but I believe it's a foot in diameter.
Wow.
Huge. And notice, it goes right up through the geologic column through hundreds and hundreds of thousands of years
The
of time.
The American Indians use it to treat bleeding.
Yeah? Ah. Here's some more. Like I say, these are not one anomaly. These are all over the place, okay? Here's in Arizona, right? It's growing right. It's still above the ground because the ground has eroded down past it. But it's a polystrate fossil. No explanation for it. Okay? Other than one event that rapidly buried life and fossil life. That fits. Okay? This is great. You have to figure out, I've got a weird sense of humor. So here's T-Rex, right? And here, you ever see one of these grabber tools? Okay? So, but the recent discovery of this fossilized grabber tool has changed how we view T-Rex's dexterity.
Oh my word.
Oh, okay. You had to be there. Okay. Here's something else. Animal trackways. Animal trackways. The most fascinating one I saw recently was where they found the fossilized animal in a layer that was, by their estimation, 10,000 years before the tracks. So the tracks are here, and then 10,000 years later, the animal appears in the fossil record. Maybe he was friends with Doctor Who, I don't know. So this is just interesting. Animal tracks and trackways are expressions made in soft, unconsolidated material by an organism which must be rapidly set or they're eroded or lost. I mean, you can't have time go past. The animal makes the footprint, the clock is ticking to keep that footprint from being destroyed. Okay? Now, you asked a question earlier about humans and dinosaurs, and I've got a couple pictures that I want to show you. I don't know that I can comment on whether they're legitimate or not. Because if you send a evolutionary scientist there, they say, oh, someone carved it, or they have 1,000 reasons to discount it. This is T-Rex tracks. Look at this one, though.
Oh my.
Isn't that pretty wild?
Yeah.
How easy would that be to carve?
How easy would it be to forge? Very easily.
Okay.
If you were just looking at the impression. But there's one that I'm going to show you in a minute that they have done some deep scanning with a computer, and underneath the human footprint they see layers of rock that are compressed under the footprint and not between the footprints. So it's not just the surface being carved away, the whole rock, when it was soft, was squashed.
Huh.
It'd be like stepping on a layer cake, right? Where the footprint was, all the layers would be squeezed, and where the footprint wasn't, it'd be the regular cake size. So, I'm pretty comfortable that these are legit. Some of them. There are a couple that have been carved, shown to be carved, and thrown out the window, just like Piltdown Man, right? Or Lucy. Remember Lucy, made from a pig tooth in the baboon leg? Okay? And it was a complete hoax. There's some like that, and it's unfortunate that those happen because they make the other ones look like they're less legit. But these things do happen. Look at these trackways. Now, here's something that's really interesting about these trackways, and it's in a lot of trackways that they find. Let's just think about this. For the flood to bury these trackways, they had to have been made before, during, or after the flood.
Before.
During.
Yeah, during. If they were made before, they'd probably be destroyed. These, many of the trackways, you'll see the animals are not la-di-dying along. They're going somewhere. You can tell by how far the feet are apart. Okay? Just like when you jog, you take a longer distance, right? You can tell by where the weight compresses it the most. And you can tell by the direction of the sand grains in the rock that these creatures were moving against oncoming water, which is really fascinating. They were running through the water. They were being swept, and so the pads were all pushing against a direction of water that was trying to sweep them away. Isn't that fascinating?
But so then how did the tracks survive against the water
That
flowing?
very quickly got filled in. So you've got some type of a mucky substrate here, and other substrates being washed in on top of it. So as their foot comes out of the track, it gets filled in behind them.
Wow.
I mean, it's just fantastic. Yeah.
So we're also saying that the human prints were made at the same time as these prints.
Well,
Are we?
that one was. Oh, which one came first? What do you think?
The human one.
No. Other one. The human was, because it's over the top of the toe. So the human was second.
I have to think this through, okay? I'm not sure I can tell. In order to tell, yeah, this seems like it'd be squashed deeper if there wasn't the support there. Okay, so it seems to me that the human came first and the dinosaur came second. Otherwise, right here, that would be bulged out. Make sense? And maybe he was after her.
Why is it?
Punch. No, I don't know. No. Okay, let me see, where am I? Here we go. So this one is known as the Zapata track. It's a big human footprint found in New Mexico. Dates back to the Permian period, which is way before the existence of dinosaurs. That's a problem. This is the one they tested to see if it was legit by scanning the rock. This is the one that causes evolutionists some serious problems. Evolutionists will totally disregard this track. Why? Because it doesn't fit their theory. We better be careful not to do that as creationists. Okay? Bottom line is, I have such belief in the Bible and I have such belief in science that we just, if it seems to go against the flood, I just need to bide my time and think about it and figure out how it fits in with the flood. So far, that has worked out with everything I have investigated. For me, the flood is by far the best explanation of what we've got. Okay. Can you see any feet print on that?
Two of
Oh,
them.
yeah, there I see it now.
Yeah, so These are not rare. Sounds like, let me read you something that Albert G. Ingalls wrote. If man, or even his ape ancestors, or even that ape ancestor's early mammalian ancestor existed as far back as the Carboniferous period, in any shape, then the whole science of geology is so completely wrong that geologists will resign their jobs and take up truck drivers. In other words, if you can show that that's a legitimate track from the Permian period, that completely blows geological timelines out of the water. Okay, here's another one. Okay? Tissue cells and collagen proteins have been found on dinosaur bones. Yet it is difficult to think that tissues could last 4,000 to 5,000 years, let alone millions. So they literally can take dinosaur bones they've dug up out of the earth, and they can take a piece of it, dissolve the calcium carbonate, just dissolve that with some acid, and they'll be left with, let me see if I can get it out here. No, that's not it. Must be here. Oh, I don't have the picture. Cartilage. Yeah, cartilage. Collagen. Sorry. Collagen. Out of a dinosaur bone. This dinosaur is supposed to be how many million years old? Collagen won't last that long. Even the evolutionists say there's no way. And yet today, bone after bone, they're testing. This is current, like today. They're testing these bones and finding these collagens and saying, this can't be. Well, what can't be is that the bones are as old as they think they are. Because collagen just doesn't stick around. Okay, number 6. Dinosaurs appear abruptly and disappear from the geologic column with no significant change. I think I might have mentioned this earlier, but here's another reason why that geologic column can't be billions of years old. When you first see the first dinosaurs, and you last see those dinosaurs millions of years in evolutionary time later, they are about exactly the same. The bones haven't changed. They haven't grown wings. They haven't learned to, sip soft drink bottles. So they don't, there's no difference. But evolution would predict that there would be a great bit of difference. They appear suddenly, they disappear suddenly, and they don't change in the meantime. That's a problem. Because you would expect that they would change significantly. We have halls that are full of these dinosaurs. Okay, Seismosaurus here. They're real. These bones aren't made up. For a time, creationists just denied that they were real. That wasn't a very smart act. They're real. So let's ask the question, what is a dinosaur? Now, that's different than asking what is a fossil, because there are fossils of all kinds of animals. But it seems like paleontologists are most interested in the terrible lizards, the dinosaurs. There's some identifiers of what a dinosaur is. All dinosaurs lived on land. So all those sea-dwelling creatures that we think of as dinosaurs, they're not technically dinosaurs. They're actually dolphins and turtles and alligators, other creatures like that. Okay, secondly, all dinosaurs were vertebrates. So is the megalodon the one who has those big shark teeth? I've got one like this. I found it on the beach out on the coast. It's the biggest one I've ever found. I have a friend who found one that was like this big in Ecophinus Springs. He was just digging in the sand and he came up with this thing. And it still has brown, it's got blood stains on it. No, actually, no blood stains. But the serrations are all there. It's fantastic. And you think, okay, if modern day sharks have teeth that are about, yay big, and they're like 20 feet long, how big were the ones with, the megalodon teeth? Okay, so not a dinosaur. Okay? Shark, not a dinosaur. All dinosaurs walked with their legs positioned directly under their body. So are turtles dinosaurs? Turtles? Not dinosaurs. So dinosaurs are a pretty small grouping, okay? Dinosaurs had 2 holes in their skull located behind their eyes. Up here. You can see it on this guy. Here's the 6 things all lined out with the circles. This is all the things that make a dinosaur, and it's actually quite a small, limited group. So, is that a dinosaur, this guy right here? Anybody know what that is?
Yep.
It's a cat.
Okay.
Is that a big cat?
Well, this is a rhinoceros. Rhinoceros or pre-elephant? What tapir? I don't know.
Oh.
I don't know. But it's not a dinosaur. What about this one? Is that a dinosaur? That's an ostrich. Well, it's an ancient ostrich, but it's an ostrich. Okay? So they all hatch from eggs, dinosaurs. And all dinosaurs, like the shark, replace their teeth periodically. So when T-Rex lost his big tooth, you just have to wait a long while, eat some plants until he got his tooth back. And all dinosaurs were cold-blooded, we think. Maybe. We're not really sure. Dinosaur? Nope. Is it a plesiosaurus?
How come?
That's a water creature.
What component of it doesn't?
Okay, it's a water creature. Doesn't live on land. Doesn't have
Oh, I see.
doesn't have feet to walk with. Okay. How about that one? Here's his head. Okay. There's his neck, and there's his body. That's a dinosaur. Yeah. So's this one. That's T-Rex. This one you can't really see it, so it doesn't make any sense to look at. All right.
Where is that?
I took pictures from many different museums. I mean, all around the world, we are fascinated with dinosaurs. I don't know where that one particularly is. I should have written that down in this corner somewhere. Next time, I guess. Okay, so here's a question that we need to think about. I get this all the time. Where did dinosaurs come from? Because they seem like they're so violent, aggressive, and destructive. But that's just this guy. And some of the littler ones, the velociraptors, this guy wasn't crazy, destructive, and violent.
He's got some pretty good teeth.
He's
Yeah,
got
but
grinding teeth.
They're all grinding teeth, exactly. Yeah. In fact, most of the dinosaurs were vegetarians. Okay? So, here's what creationists believe. A lot of creationists. Dinosaurs either are creatures created by God and corrupted by sin. Okay? I mean, like the lion or the owl or the hawk. Or the result of genetic tampering by corrupt humans. Now, in this age when we can glue and make animals with genetics, we understand that a little bit better. Many died, were fossilized by the flood. A changed earth provided no acceptable habitat and survivors died out. Dinosaurs. So there are turtles. But turtles aren't dinosaurs. They're alligators. Alligators are not dinosaurs. When we talk about the dinosaurs, that's a very specific group. And are there any living dinosaurs? Dinosaurs. It's a good question, isn't it? It's a very good question. Evolutionists. What do they believe about dinosaurs? They're the descendants from the same common ancestor that all other living organisms come from. So they're related to us. They evolved to be very successful during the Mesozoic era, but when Earth's climate was changed by the impact of a comet or an asteroid, think Yucatan Peninsula, they died out. What do you think? Where do you think the dinosaurs came from?
Have you been to Meteor Crater?
Amazing.
Yeah. Huge. I mean, unfathomable. It's so huge.
Whereabouts is that?
Arizona.
Arizona. No, I have not. I'm a Canadian. I have traveled a lot down here.
You need to travel.
Yeah. I haven't even been to the Grand Canyon. Can you believe
Oh
that?
my gosh.
That,
And that's a hard one to see by pictures.
Yeah.
Yeah.
Sure is.
Yeah. Dinosaur? Yes, dinosaur. Plant eater, by the way. Yeah. How about this one? Dinosaur?
Yeah.
That's a woolly mammoth.
That's a woolly mammoth. Absolutely.
can't
It's
be
not a dinosaur. So we call many things dinosaurs that aren't really dinosaurs. How about this one? Dinosaur. Triceratops, right? All right, so let's talk about paleontology for a minute. An imperfect process of finding, articulating, and guessing from meager, maybe I'm a little bit over the top, but it's like we're just guessing. Meager evidence, the musculature and external appearance, gender, metabolism, diet. Listen, when you find bones in the field, there's not a lot of information. Most of the bones are fragmenting and falling apart. When you go to the museum, are those the bones? No. Those are plastic copies of the real bone. The real bone is so incredibly fragile that if they tried to build the skeleton, it would just crumble. Okay? So you've got these crumbling bones. It's very difficult to try and figure out what kind of musculature is on them. You can put them together like this and get a basic plan, but when you start trying to figure out, okay, so it's going to be origin and insertion here for pulling the leg back, how big, how beefy is that muscle going to be? I mean, you can do scientific calculations, you can look at other musculatures, you can estimate the weight of the animal and how much muscle power be needed, and you can build something. But when you see three-dimensional, fully built dinosaurs with scales and skin and all that kind of stuff walking around, you have to realize that that is a guess. A very educated guess, but it's a guess. So we have to make sure we realize that there are limitations to what we've done. There are many things that we can learn from this research. Okay? Average size of a dinosaur is the size of a sheep. You take all the dinosaurs and average it all out, little sheep. Okay? When you think T-Rex, Seismosaurus, but the average size of dinosaurs is the size of a sheep. Okay? Largest dinosaur egg, size of a football. Dinosaur egg. So even those great big guys came from a little wee tiny egg. Dinosaurs are never found with mammals. Based on the vegetative fossils found with the dinosaurs, it seemed they lived at sea level in warm, humid swamps. What does that back up? Something else we've talked about. Yeah.
One of the first ones to get.
They're going to be one of the first ones to get buried after the aquatic animals. Dinosaur? Nope. That's the one we saw giving birth a little while ago. Yeah. But what's really interesting about them, this one, you see this bone, the donut of bone? The eyeball's in the middle of this, and around it is muscle. So this dinosaur was able to really, almost like a, what's the lizard? Chameleon can move his eyes all over the place. It's thought that he might have had vision like a chameleon so that he could focus on two things at once. Fascinating stuff. Lots to learn from dinosaurs. I could probably
You
skip
just
this.
said that wasn't a dinosaur.
Oh, yeah, you're right.
And then
Well
you said,
said.
okay, so
Well said.
that one's not a dinosaur.
Not a dinosaur,
But
but
we can learn really cool things about it.
yes,
And it's old.
and it's old. And it's a fossil.
Okay.
Okay, that is a dinosaur. Look at the tiny little head on it. Plant eater. It must have eaten a lot of plants. Yeah, just constantly eating. Okay, you've heard of dragon legends? Okay, where do those dragon legends come from? Are dragons real? Legitimate? Like winged dragons? Seriously? Well, it's really interesting. Could the things in dragon legends be dinosaurs? The Bible contains references that sound an awful lot like dinosaurs. Listen to Job. Job says, he eats grass like an ox. See how his strength is in his hips. Think which dinosaur has lots of hips? Like, he's mostly hips. Is except for his grabber tool, right?
That-
The T-Rex.
yeah.
But it says he eats grass like an ox. Did you know they find T-Rexes and they evaluate the teeth, and many of the teeth have chlorophyll stains?
Huh.
T-Rex may have been mostly vegetarian. Just because he has teeth like that. I had an iguana that had great big chompers, but he was a vegetarian, completely. Look at this, and his power is in his stomach muscles, and if you think about the T-Rex, everything he did would have been with his stomach muscles. Okay, keep going. He moves his tail like a cedar. Okay, boom, boom, boom. His sinews of his thighs are tightly knit. This sounds like a T-Rex.
Yeah, it does.
How about this one? The sea serpents in the water. In Psalms, it talks about sea serpents. That's interesting. How about this one? In Isaiah 27, the fleeing serpent, Leviathan, that twisted serpent. He will slay the reptile that is in the sea. So it's a reptile and a sea serpent. The viper, the flying serpent. How about this one? This one really is interesting. This is in Job. His sneezings flash forth light. You ever hear of the bombardier beetle? The bombardier beetle is this beetle that has two chambers in its back end. And when the contents of those chambers get mixed, it turns into a boiling mixture of gas. The bombardier beetle uses this. He has a little nozzle that he can aim. So if it gets attacked by something, he can aim his nozzle and blast him with burning liquid. And it's left alone. Bombardier beetle. In the heads of many of the dinosaurs, there are chambers that they've wondered, what are these chambers? You know that extra hole?
Huh.
They've got eye sockets, they've got nostrils, they've got a mouth, and then they have these two chambers that are walled off from each other, kind of like a sinus. Could they have been like the bombardier beetle? And they create these two chemicals that apart are harmless, and then they mix it and sneeze it. Okay, I'm going a little bit too far here, do you think? Or maybe not. Listen to this. His sneezing flash forth lights. His eyes are like the eyelids of the morning. Meaning they look like sun, so bright yellow eyes. Out of his mouth go burning lights. Sparks of fire shoot out. This sounds like a dragon, doesn't it? Smoke goes out of his nostrils as from a boiling pot and burning rushes. His breath kindles coals and a flame goes out from his mouth. Maybe this was God's answer to helping Adam and Eve have a campfire when they got cold. You know, they call over the dragon and say, sneeze on this. I'm cold. Isn't that fascinating? To me, that's absolutely fascinating. So let's look at some other fossils. Okay? Any idea what that is?
Yeah, that's what I was.
Saber-toothed tiger.
Oh yeah, look at the teeth.
Look at that head on that thing. Wow. That's amazing. What about this one
Looks
on the
like
left?
Cheetos.
Yeah, that's right. That's right.
Cheeto head.
Yeah, somehow I don't see him doing the...
Oh, you took it away.
Oh, sorry. What do you
And
see
the
that as?
T-Rex?
Yeah, it's a T-Rex. That's an actual skeleton, but can you get a sense of how fragile it is? It's inside glass. That should tell you something. Okay? So, 3,241 different kinds of organisms have been found so far that are both well represented in the fossil record and alive on Earth today, with very minor differences. So far. How many? 3,241 animals that we have around us today can be found as fossils, and when we compare the fossil with the living creature, there's little to no difference.
Cockroaches and alligators.
Yeah, well, there you go, cockroaches and alligators. So, tell me what that is.
Bear.
Not a bear.
Yeah,
It's a
sloth.
sloth. See the back legs?
And the head.
Now, it's much bigger than the sloths we have today, but it's near identical. Okay, here's a list of some of the things we have. Okay, the ginkgo. You can find the ginkgo, and these are just evolutionary years. I'm just going to let them be. The ginkgo hasn't changed in 252 million years. The Cove redwood not changed in 151 years. Horsetails haven't changed in 361 million years. I mean, look at this. The annelid worm hasn't changed in 488 million years. The sea mussels, 419 million years.
I know why the
And they do
cockroaches
the
haven't
same.
changed, because you can't kill them and it's
Yeah.
still the same ones alive.
Ants are like that too. Okay,
Yeah.
tell me what that is. A
Oh my
bee.
gosh, and honeycomb.
Yeah. And honeycomb.
That's amazing.
Fossilized honeycomb. Sweet. How about this one?
Bird.
That's a rooster.
Oh, yeah.
Chicken. Well, rooster. Okay. How about this one?
Ginkgo.
Ginkgo.
And amber.
And amber with a what in it?
Centipede.
Centipede. How come you guys, you must be paleontologists. What about these ones? Tell me what this one is. Dragonfly?
Frog.
Frog?
Fish.
Well, actually, that's a stonefly. That's that little thing. They make little tubes underwater, and they live in streams. Okay, make great fish bait. How about this one?
Seahorse.
Seahorse,
Tarantula.
tarantula,
Tarantula.
another spider. Isn't it amazing that when you start looking at all these fossils, you recognize them?
Monkey.
It's a monkey.
Yeah.
I mean, bam, monkey. That's easy. How about this one?
Lobsters.
Okay,
Mosquito.
lobster or crayfish up here. I think it's crayfish. It's smaller.
Yeah.
What's this one? Can't quite see the tail.
Yeah, I was gonna say scorpion.
Scorpion. And that one,
Looks like a
they
mosquito.
could, look at this leg.
Oh,
Great
grasshopper.
jumper. Grasshopper. Grasshopper. How about that one?
That's a
That's a
It's a
mosquito.
Minnesota state bird.
Yes, it looks just like what I have when I go like that, and I lift my hand. It's like, yeah, that's it.
That's about the size of some of them.
Exactly. Exactly.
How about this one?
Palm tree.
It is palm, palmetto palm.
Yep.
Yeah. That's in the fossil record.
It's amazing.
So at the time of the flood, Noah would have seen monkeys and grasshoppers, and they've been with us for a while.
Yeah, he brought two with
Palm
him.
frond. I hope he didn't bring them.
I bet he did.
Yeah. Okay, help me with these ones. Up here.
Tortoise.
Sea turtle.
Yep. Octopus.
Octopus.
Bee.
There's a housefly.
Yeah.
How about this one?
That's what it looks like.
Sea worm.
It's dinosaur poop.
Is it really?
It is.
You're good.
I just thought you'd have to see that. Okay, here's a fish, beautiful fish. Look at the bones. Any of you have filleted fish? It's like, yeah, that's what's in them. Okay. Isn't that a neat comparison?
Wow.
I saw this and it's like, I've got to go find a tiger butterfly. So I found one, stuck it in there. It's like, wow. Yeah, it's all there. It's all there. You're looking at fossils. What do you think? You ever have those little guys in your house running around on the walls? Yeah? Yes?
That looks like one of those swimming ones, though. Oh, jeez. It is goofy.
You know I've got a twisted sense of humor when I do that to you. All right. Yeah. Yeah. Okay. Well, that was fun. How about this guy?
It's your
Megalodon. Okay? You pick that up along the seashore, that's a pretty good tooth. What are those?
Oh my gosh.
Yeah, I bet you some of you have those type of edge ferns in your gardens. We already saw this guy. Okay? Maybe I'll show you one that looks a little bit more like a
Bird.
bird. It's all there. 3,164 is that number I think that was? 41. They're all there. They're all there. What does that mean? It's like, okay, so what, Tim? You showed me all these cool fossils, but what does it mean? It means that things are not so different. We can go back to what evolutionists will call billions of years and have the same creatures we have today. So you don't have to take this fossil record and be like, oh no, he's bringing out the geologic column. You can be like, bring it on. Oh, isn't that interesting? What's that? You think jellyfish tastes good. There you have a shrimp. Huh? Yeah, some type of little crustacean crawling creature.
And just like they said, the coelacanth died out and now.
Coelacanth is a really good example of evolutionists jumping the gun. Why did they want this coelacanth to be gone? Dead and gone? Because it's so old. They find it so far back in the fossil record that if it's still around, that blows billions of years away.
Yeah.
I mean, for something to exist for billions of years,
With no evolution, right?
with no evolution, it's the same creature.
Same thing.
See, that's what we're doing here. We're looking at some fossils and saying, hey, listen, what kind of tree is that?
Maple.
How did you know that? That's a billion-year-ago maple. No, it's a maple. It's real easy. What about that one? It's a gator.
Crocodile?
Gator.
I think it's a gator. Its head is sideways, so you can't really tell whether it's got a narrow or a fat snout.
Yeah, crocodile snout's narrower.
Yeah. Yeah, so this is, the head is turned sideways, so you'll only see from the side. Okay, that was fun. How's our time going?
4:45.
It's 2 hours.
Do you see why I can't get through all these? It's like there's so much information there. But I want to tell you about the Grand Canyon. So, 4:45.
Tell us.
Let me give you another
Go ahead.
15 minutes. Can we do that? You guys will still come back later?
Yes.
Okay. As long as you promise not to abandon me here. So let's talk about the Grand Canyon. The Grand Canyon is this huge, beautiful, amazing canyon. And I speak as one who has never been there. But I've seen pictures. I've read things. It's gorgeous. It's huge. 277 miles long. This is not small. This is ginormous. It has the Colorado River running through its length. Okay? Yeah? It goes between 3,000 and 6,000 feet deep, between 4 and 18 miles wide. This is one huge canyon. Vertical cliffs. This is a vertical cliff. Now, that's important because if this Grand Canyon were millions of years old, what would that side of the cliff look like? Because it's constantly losing rock and falling. You can see it down here. This is called talus. If it's millions of years old, it should slope like a big U. But most of the canyon is vertical walls. That argues that this canyon has to be young.
Yeah, they said it's all carved
Has
out
to
by
be
the
young.
river.
Okay? There's a problem with this Colorado River. Uniformitarianism would say that this river has always been at that volume. How did they come out with millions of years for the canyon? Well, they figure out how fast the erosion is taking place. They divide it by the number of years it will take, and that's why this canyon has to be millions of years old. Because, by uniformitarianism, the only thing that's ever gone through this canyon has been that size of a river. Is that good logic or bad logic?
Bad
That's
logic.
evolutionary logic, but it doesn't fit. You see, there's no way that that could carve out that canyon and it be in that shape when it's done. If that river's what carved out that canyon, then that canyon would be more of a valley than a canyon.
And the other thing is, not to be really obnoxious, but they've obviously never seen it when it rains in Arizona. That river would fill the whole thing because the flash floods in Arizona every time it rains because it's so dry. When it really pours,
It just runs off.
it runs off
Flash flood.
and it floods everything.
What's interesting
Yeah.
about the Grand Canyon is that it's carved through sedimentary layers of rock. From the top to the bottom, even from the air, you can see the layers, one after the other, all not metamorphic rock, but sedimentary rock. Limestone, sandstones, and shale, and into the metamorphic schists at the very bottom. The bottom of the canyon gets to the, I can't think of the border. It's called the border. It's called the, what is it called?
Not bedrock.
No, I'll think of it. It'll come back. It's important. GC border. It's the border between sedimentary rock and rock that was not eroded by the flood. It's the boundary between rock that has been always where it is and rock that was deposited during the flood. So you could call it bedrock, sure. Okay, it exposes geologic layering, some of which extends around across the continent and around the world. And the boundaries between the layers of rock do not show erosion. So if you study the Grand Canyon, you study a canyon who has clean boundaries between each layer. So when you study it, you just have to admit that this was laid down one layer at a time, very rapidly, until the top. Now, one thing you have to keep in mind is the top of the Grand Canyon is not the top of the original deposits. Because there's buttes that are above the flat plateau of the top of the Grand Canyon. And those buttes actually will show you the top layer of where the deposits came to. So before you even get down to the Grand Canyon rim, you've already eroded a vast amount of sediment. How do you erode sediment that is hard as rock? You can't. I mean, you can, but it's a slow process. It would take millions of years. But when you think of the layers being pliable, partially hardened, and a great vast amount of water flowing over it, you realize that it could be eroded very rapidly. You see, if that river was the only thing, this is the type of canyon you'd have. We don't. We've got very tall canyons. So here's a question for you. If the amount of sediment that has been eroded and moved was all the way to the tops of the buttes, where did all that sediment go? We're talking about enormous amounts of debris that are washed out of the canyon. So, okay, we've got all these sediments. You can look in front of the canyon and say, okay, where are all these sediments? Mexico is. No, it's a big question. See, when a river erodes like the Mississippi, it produces a, what do you call it down here?
Delta.
A delta. Where's the delta at the end of the Colorado River? There isn't one. That's a problem. That's a problem for evolutionists. Because they believe the Colorado River washed the Grand Canyon contents out. But there's no delta. Where are the contents of the Grand Canyon? Now, if you're a flood geologist, you're going to say, well, that's easy. Spread out around the world. The contents of the Grand Canyon are the very things that created the layers in other places. You see, that fits, doesn't it? That's one of the things that I love about creationism and the flood geology, is that a lot of it makes sense. Okay, I'm going to skip through some slides here because we've already talked about them. I'm trying to go in a little faster speed. Okay, we talked about that. Monument Valley, Stone Buttes, we talked about that. No Delta, we talked about that. Oh yeah, there's some of the buttes. Aren't they beautiful? So we're talking about thousands of feet of material. Go to the top of that and then just spread that all the way around in every direction. So it's the amount of dirt washed out of the Grand Canyon is small compared to the amount of debris washed out above the Grand Canyon. Does that make sense? Okay. Here's where we're going. Canyons can be cut out rapidly by a high volume of fast-moving water. See, water, when it's traveling very quickly, will literally scour. Water pressure, when it's pushing down, will literally roll rocks along. Water, when it's going past a solid surface, will do something called caulking. Caulking. as it goes past, it creates a vacuum that will form and then crash, form and then crash. And in the process, it's like a jackhammer that will literally erode. The Glen Canyon Dam, I believe, has a spillway that they had to use extensively because of flash floods. And when they did that, they had the water going through that spillway so quickly that it started caulking. It started creating, and you could feel it in the ground. So they shut it down and went in, and they found huge, like, places in their spillway that they had to fill with concrete that took like 50 concrete trucks to fill, that had just been pulverized by the caulking and then washed out by the water. So water can do more than just wash stuff away. It can literally pulverize rock and take it away. And so here we have, if you've got a high volume, fast moving water, you can erode very quickly. Add to that, if the layers are not solid rock yet, if they're just slowly, what was that word, diagenesis? If they're slowly drying out and hardening, they're going to be much easier to erode. And so as the flood is receding, it can take with it a lot. Have you ever built a sandcastle on the beach? The wave hits it, it survived. The wave goes back away from it and sucks most of it back into the ocean. Have you ever seen that? Water can do that. These erosional forces would only be heightened if the layer they're cutting through are relatively soft. Okay, so here's your processes. There's your layers. Okay, you have cavitation bubbles, you have caulking, you have suction. Okay, have you ever been in a riverbed and you see these big holes? Call them kettle holes. Okay, all that can be done by the water. Have you ever tried to stand in a stream and it takes you over? Yeah. Okay, so here's what the problem is with the Grand Canyon. It has to be washed out by something other than the Colorado River. Why? Because there's all these side canyons, that we call them blind canyons, that are dry. I mean, okay, over here the Colorado River is running through, but what about this canyon that goes way back and it's way deep? What washed that out? Oh, the Colorado River took a Yui, went in here and washed. No, it's just not going to happen. So this gives evidence that the water that washed through the Grand Canyon didn't come in one unidirectional way. It came from all around the Grand Canyon, that whole plateau, and washed down into the canyon and washed it away. That makes sense, doesn't it? See, one proposed possibility for the erosion of the Grand Canyon is the rapid drainage of water that had been dammed up after the flood. When this dam broke, water was released and flowed rapidly, carving out the Grand Canyon in the relatively soft rock layers left by the flood. Okay, so here's what the logic is. After the flood, all these layers, all the way to the top of the buttes, were left. They were slowly starting to harden. But upland, there was this huge lake, the size of all the Great Lakes together, that was being held back by a dam.
That's the Bonneville,
Okay?
right?
Yeah.
The prehistoric.
Yeah. It's and then at some point, maybe a rain shower, maybe, something happened that it weakened. But it busts the dam, and this wealth of water flows down across the Colorado Plateau, takes away all the stuff between the buttes, and as it's draining, goes into the Grand Canyon and sweeps away fast-moving, huge volume of water, and you form the Grand Canyon in a relatively short period of time.
Is that the same event that then created the Snake River Canyon and from that Bonneville River?
Yeah.
Yeah,
So the question is, and I think you're leading us there really well, is there any other examples on Earth of this happening? And the answer is yes. Lake Missoula. Lake Missoula was a lake that was created by the melting of glaciers. Okay? Melting glaciers in the north, up in Saskatchewan, Canada. But when it came down, it was held from completely washing out to sea through Washington State by an ice dam. You can see what's coming. The water levels build up, build up, build up, build up, build up, and finally the ice dam melts to the place it breaks open, and the water rushes to the sea. And it leaves all these evidences of fast-moving erosion all through Washington State. Let me see if I can show you some pictures. This is called Dry Falls. Okay? This is bigger than Niagara Falls, but very similar. It has a plunge pool. You see these plunge pools? There's three.
Yeah.
One there, one here, one here. Where water came plunging over and made a big hole. You find it at Niagara Falls. Same identical thing. But what do you notice isn't happening right now?
There's no falls.
There's no falls. It's called Dry Falls. So there was a investigator named Harlan Bretz. Okay? He was studying this area and he's like, water must have gone through here. He pointed out that it contained major drainage features, meaning dry falls right here, sandbars, plunge pools, potholes, those are the ones that are carved down into by the spinning of water, dispersed boulders, huge boulders in the middle of nowhere. Where did they come from? They'd been rolled along. And he hypothesized that the geology was the result of a catastrophic flood erosion. In other words, lots of water over a short period of time. When he presented this, he was laughed at. Laughed at to the point where he was excluded from the scientific community. They wouldn't publish his papers. They wouldn't allow him to present. They wouldn't even allow him to come to the geology conferences. Could you imagine that? Well,
Unfortunately, yes.
after 40 years, a geologist happened to be going through Washington State. And he comes up to this place. He says, geologist asks, how did that form? You've got this riverbed come along and it must have gone over here. And look, there's a plunge pool. And then there's a drainage basin goes off. This is what you'd expect if there was a lot of water going very quickly over one area of land. And he went to the scientific community and says, Bretz was right. They apologized to him, pulled him into their circle, and things were fine. I mean, that type of a situation, that type of geology doesn't just happen. You can back up and say, okay, here comes the water down through here, plunges over. Look what it created. It eroded all this area. How did this form? Well, this has so many of the same features that Grand Canyon has. So they started backing up and looking at a bigger area, and this is when they started thinking about Lake Missoula. He hypothesized, he guessed, hey, if we look around, we're going to find that at the end of the Ice Age, meltwater was trapped in the mountains of Montana, were released over the eastern part of Washington State at a speed of 60 to 80 miles an hour and 300 to 1,000 feet deep. He hypothesized all this. And what the geologists have been doing since is finding evidence to back up just what he hypothesized. Most of the majority of geologists are like, yes, that's it. The thing is, the Grand Canyon was created in the same way. So either you have a river present, in the Grand Canyon you've got a river present, but it's far too small. You've got sheer cliffs. You've got a lack of talus, rocks that fall down. You've got hanging waterfalls where there's no river. You've got erosion debris are all gone. It's the same thing. Okay, but that's not the only evidence we can look at. We can look at something called Mount St. Helens. Did you recognize it? Okay, look at the difference before and after. I mean, a huge amount of matter is gone. Well, in Mount St. Helens, when it blew, it created this incredible valley full of layers. I mean, Mount St. Helens, even though it seems like it would only create one thing, if you went down in this valley, you'd find layer after layer that was easily distinctive, it was smooth, and it was different matters. All these layers. So to think how long does it take to make the geologic column? Not long. Not long. Later, I'm just going to zip through a few things. Later, it was eroded when Spirit Lake blew its banks and flowed down. Lots of water going really fast, short period of time, and it created this. It's called the Little Grand Canyon. Can you see the river? Here's the river. Just a little bit you'll see going through. Did that river make this big canyon? No. This canyon was formed in a matter of days. All that stuff gone. A matter of days. Where'd it go? Downstream. But the water was going so fast and so intensely, it carved it quickly and left. Look at these. Does that look familiar? So we have these two events, these two things, Lake Missoula and Mount St. Helens, and it just helps us to understand what happened at the Grand Canyon. I could keep going on. There's so much about Mount St. Helens. You ever wonder about those vertical trees in the geologic column? How do you get a vertical tree that's got no roots? It's got a root ball, but it's been torn out of the ground. And it's got no branches. How do you get them vertical in the geologic column? Well, it's interesting that, let me see if I can get a piece of this, that they found these trees that have been knocked down by Mount St. Helens, the blast, floating in Spirit Lake. And guess how they were floating? Root ball down, branches up, and as the debris settled to the bottom, it replanted them.
Wow.
So they were trees without a roots planted in volcanic ash. Okay, it's time, isn't it? 5:03. Well, I'll just skip radiometric dating. That's cruel, aren't I? God bless you all. I'll be back here at 7 for the next part. Get yourselves some sustenance, and when you come back, we'll talk some more.